so we learned about different concept in cryptography. We learned about symmetric key cryptography, and then we also talked about asymmetric key cryptography and also the hash function. We also talked about crypto wallet and crypto wallet. We also talked about the uses of cryptography in blockchain. We talked of like 5 benefits of cryptography, not only in blockchain but in day-to-day application. That is when you're using your Facebook, your passwords, your phone pin. It's a form of encryption. WhatsApp uses end-to-end encryption method for chat. The same case for Telegram. Yeah, messages are encrypted. So we talked about the 5 benefits. That is the avalanche effect, the uniqueness of every input. It's deterministic. So the same output, any input will always have the same output even if passed through the hash function. So there is the quickness of the encryption, and then we have reverse engineering is possible or is not possible, not impossible. It's not possible because we have other types of cryptography mechanism or methods that you can be able to reverse engineer. Then we talked about crypto wallets. We talked about crypto wallet and like a way to show you that your money is in this blockchain. Yeah, it's just a receipt of it's just a way to show you to uh, retrieve and spend your cash. Also, so the different types of crypto wallets. We talked about the online wallet, mobile wallet, and desktop wallet. We also spoke about hardware wallet or hot and cold wallets. So cold wallets, these are hardware wallets. They don't require internet. They operate offline. Then we have hot wallet. Hot wallet are an internet-based wallet. And then we saw that cold wallet are normally used by exchanges whereby they are able to safeguard their private key and assets on offline. So we talked about ways to secure
Recording
cryptography,
in progress.
ways to secure. Hey, could you kindly? Yeah. Okay. So we talked about ways to secure your cryptocurrencies. So use a cold wallet, use a secure internet, maintain multiple wallets, secure your personal device, change your password regularly, and do not get phished. So you have to be keen. Any change of word or any change in letter, like this one is bit novel, it can be changed to be TI novel. But since you are not keen, you if you are not keen, you are not able to like know that the I is supposed to be between B and T. So that's how most phishing website or malicious actors in blockchain do. They normally change one letter. Then most of these wallets do not actually have, they don't offer support on retrieval of private keys. They don't offer support on retrieval of private key. So today I was reading about a family in US that apparently they never waited they never waited for the JSON or the JSON or the private key to complete downloading. So right now they are actually requiring or looking for help because their wallet has like around 5.8 ETH 5.8 million USD. So that's a lot of money. And that from the story they were talking about, like they bought Ethereum when Ethereum was actually doing a pre-sale, when they were doing a pre-sale. So they had they have a quite a lot in their wallet. So that is something that you also need to take care of, or to make sure that you have your backup of your private key, either on your local hard disk, all in your cold storage, all in your email. Just make sure you have a copy of your passwords, or a backup of your password. Then we talked about the security, or consideration for security, wallet security. So one of the consideration is that they consider cryptocurrencies in the wallet. The wallet can be able to hold, or the wallet holds, because there are other wallets. From what we have learned so far, we know that there is externally owned accounts, and then there are wallets that are owned by they are still part of externally owned accounts, but they are owned and managed by the exchanges. So you also need to, like, the standing point of the company, where the company stands on security, and whether it's an uncustodial wallet or custodial wallet. If it's a custodial wallet, you need to, like, know whether the company is legit, or whether the company has had bad review on the internet, and then the backup feature the wallet provides. Yeah. So those are some of the things we talked about, and we also I also did a presentation on the different application of cryptography. So I showed you how to, like, create a Caesar cipher. I also showed you how to do advanced encryption standard, that is the EAS, and then that is the asymmetric encryption, and how to encrypt and decrypt the messages using the private key. This one, other part I never showed you. This was to, like, encrypt a block, or an array of data. Like, how can you be able to, like, encrypt array of data? This one I left as like a to do. And then I also showed you how to generate phrase word using BIP39. Yeah. And yeah, so I can actually learn this again, and uh, sorry, and see some of the output that we saw on Friday. So node JS. Then these are some of the output. So this is the first one, the Caesar cipher. This is the encrypted data. So this is the output of the encrypted data. This data. So the word hello world.
Hello, we are
Then,
not seeing that screen.
oh, sorry. Let me just share, like, okay, yeah. Now you can, are you able to see now the VS code?
You can see it now. You can see the VS code.
Okay, so this is the output of this line number 7. So this is the hello world, the input, which is hello world. The output should be like that. So this is the output, which we have encrypted using the Caesar cipher. And as you can see, it's just a shift of letters, and an addition of just a few letters which are not normally used. And then we have simple ciphers are fun. which is another encryption. This is actually a decryption. Yeah, we are decrypting simple cipher fun. So this is the output of simple cipher fun. And then this is another encryption whereby I'm encrypting the Africa Data School, which is supposed to produce this, and then decrypting the word again, the sentence, Africa Data School. Then we have this other encryption, that is advanced encryption standard. Sorry. So this is the message that I'm encrypting together with the secret key, and then I'm console logging it. So all this is I've console logged. So this is the encrypted data together with the private key, together with the private key. Then on decryption, I'm decrypting the ciphertext, this word, using the secret key, that is 123, and then this is the byte or bits of words. So this is the ones and zeros or numbers in uh, bytes, that is. So each letter represent a character in the alphabetic. So if you have done binary and hexadecimal, normally have ones and zeros. So words are converted into ones and zeros in computer, and then that is the binary. So we may have data, like let's say data being represented in such a form. So this is how machines are able to like learn, or not learn, but understand. It's called the machine language. Yeah. Then we have other letters, because the letters normally starts from 0 to 9. So they added some few, that is it can either be octal or hexa. So hexadecimal has A, B, C, D, E, F up to F. So A representing 10 all the way to number 16. Yeah. So this is the binary, the header code. Then we have the message now, the original text, after now converting this into a string that the human can be able to now understand. This is the message this is my message. Yeah. Then we have encryption with an array of, or an object of data, So you can have like the name here, like your name, then the second line, not like that. You can have an object inside here, so with name, name like that, and then so this one could be representing information of a person. It could be representing an information of someone's information. So let's say, just say the ID is 1, and then let's try to learn it again. And okay, sorry, I didn't save it. Yeah. So this one is a bit encryption of on an object, encryption of an object. So as you can see, this is our data. This one could be representing an information or someone's data uh, in a system. and you want to save that object of a person. So like all the details of a person, like the ID of that particular person, the name, the email, and everything. So you encrypt that data, and then uh, using the secret key. So with this, you can like be able to encrypt multiple records in a system, and then you're now using your secret key again, and then you are now decrypting on the online 38. So this one is how you decrypt back to the original data. So this is back to the original data, the object that I was talking about. So this is the encrypted data. So the more the longer the longer the data which is being encrypted, sometimes the characters also increase. Then we have generation of phrase words. This is how you generate them, the mnemonic words using by P39. Yeah. So that's what we did on Friday. On Friday, I hope you were able to like experiment and see the different methods of the different ways you can be able to like implement. I also provided some tools that you are to download. Hope you were able to set up the environment, because this week we will be requiring it to do the smart contracts. Then I have something else to show you before we start on the today's lesson. That is the smart contracts. It's still on encryption. So I created a simple blockchain for demo purposes, the same as the one the one we have been using for demo practice. So this one I was using the same. Oh, sorry, there are some other things that I was doing on this code. To do something with geodata or GeoJSON data. Okay, so just okay. Nice. Now we have, yeah. So I was using the same library. I was still using the same library. That is the crypto-js. So as I had stated earlier, this library contains or has a lot of uh, encryption methods. So if you go to your root, normally there is a folder that is generated once you if you are creating using Python or for Python. I don't remember the name of the uh, library. Yeah, it's called library. But for Node, it's called Node modules. So under Node modules, this is the package that I have installed, crypto-js. So if you go inside to crypto-js, you'll be able to like see the different encryption methods that are there. So this is the secure hash 1, secure hash 3, secure hash 224, 25, 384, 512, and also the likes of MD5, uh, this MD5 it should be, yeah, here. This is the MD5 .js. So these are methods and functions that will enable you to encrypt data using the, as you can see, these are now the numbers, how they are represented, like A is to 7 or 0, that way. So those are the kinds of the characters of the numbers that will be represented by that particular hash. Uh, Yep. So that is the MD5, and then it's been this class MD5. It's been exported as a MD5, so that it's easy to use. Instead of coming up with your own encryption, you just use ready-made library to help you in your development. So this is a simple blockchain representation that I used, that I created using the secure hash 25 seeds, because secure hash 256 is mainly the one which is used in blockchain, most blockchain, like in Ethereum, and that's what we are studying. We are studying Ethereum. So sorry. So let me just explain the code, the way it works. So I'm initializing or requiring the secure hash 256, and then I'm using class approach in Node.js, where I'm creating a class called block. And in this particular block, I have a constructor with parameters index, timestamp, data. This is the data that is supposed to, like, the user data. That is the information about the sender, the amount of coin, the transaction address, the receiver address, and then I have defined the previous hash as an empty string. It's because it's a long string, so I've defined this parameter as a string. And then the hash, which is the computations of this hash, is equals to computation hash. So this is another method that is now encrypting or computing the hash, and it's a combination of the index, the previous hash, the timestamp, and the JSON.stringify JSON data, which is a combination of data plus the nouns. And for my nouns, it's 1, because it's 0, because I haven't even created a transaction. Then below there, I have what is Ethereum was using. I don't know, yeah, whether they have actually upgraded to proof of stake, but you're still waiting. So this is a proof of work, the difficulty. So I've created another method called proof of work with difficulty, and then it's a combination of the difficulty, that is the nouns and the hash, and also the computation hash, this one. So that is the level of difficulty. And then we have the blockchain. Now the blockchain itself, and I have a constructor with a variable called right ideas blockchain, and then I have which has the start genesis block. So the first block to be created, it is always called the genesis. It starts from 0, 0, it starts from the 0 address. So if your contract has a burn function, uh, excuse. So if your contract has a burn function, all the invalidated coins, or all the rejected coins in a blockchain will always go back to the genesis block. And if you are creating a token, they will always start from the genesis block, and the same thing for the blockchain. So then we have here on the blockchain, so we have added the level of difficulty, which will be this part, which will be used here. Sorry. Then we have the genesis block, the timestamp or the initial block in the chain, starting with the date, with with block 0, the date as the timestamp, the data as the initial chain, and then we have the hash as 0. So this hash, we can actually add something and make it start at 0, 0, 0, 0, 0, 0, 0, 0. It can start from that previous hash. So this is the previous hash. This will be the previous hash. Then we obtain the latest block. So to obtain the latest block, we do the right ideas blockchain, this here together. So this right ideas blockchain has the genesis block. So the previous hash or the latest block will be uh, added all. We'll, we'll get it like that. And then we have another method or function to add a new block. So we'll have new block.previous with this other class. So this will be the new block now. And then we will add the proof or the difficulty. And then we will push this now new block to the right ideas blockchain up here in our constructor. Then we will check chain validity. We'll check the chain validity, whether the block and the hash, if the current block.hash is not equals to the current block.computation hash, then we will return false. And then if check block.previous hash, if it's not equals preceding block, it should be previous block. Should be previous block. Yeah, should be okay. Anyway, previous block. Then we should return false if. Just a minute. So the current block dot previous hash, it shouldn't be the same as the preceding block if it's not, it is equals or not equals to it shouldn't equals to the preceding block. So the first hash, what I'm trying to do here is that the previous hash should not be the same as the preceding block hash, or the block that is the next. It shouldn't be. So here I'm console logging the process in form of JSON data. So so this is the before we get to the output. Before we get to the output, I have initialized I have initialized a variable called Litecoin as a simulation to like assuming that this is the name of our coin, so that I'm able, and then this is the new blockchain, the function over here, the method of the class above. So this class has everything. Yeah, it has all we have actually defined everything in our class: the hash, the previous, and the validity of the block. We have added the difficulty in it. And then this is now our coin, assuming this is our coin called Litecoin. And then we have Litecoin dot add new block. So this coin of ours, we will add it to a new block once we do like a transaction. So in this new block, we will have the date, we will have the index, so it will be index one, because we are starting the block from index zero, because once you create a blockchain, nobody has actually started using the blockchain, so it will start at the index zero, and then for the new transaction of the new block, it will start at index one with the data. So this is the data that we have, that is of the sender one, and recipient one. So this, imagine this, you now sending to someone else, quantity or the price or quantity of the coins that you are sending, that is 50. And then we have block 2, which has the same details but different quantity. And then now we are just console logging the output of the Litecoin. So this is the output here. So we have right ideas blockchain, the name of the blockchain, and then we have index zero, the timestamp data of it's the initial block in the chain. And then we have the previous hash, which is zero, and then we have now the hash. So this hash should not be the same as this should not be the same. So the previous hash should not be the same as the preceding block. It shouldn't. It should be different. Yeah. And then we have the nouns, which is just a counter. So we have just implemented it just like that. I have just implemented just like that for demo purposes. So is, if you can see here, I'm just adding the number from the previous one. I'm just incrementing the number. So there is a better way you can be able to implement it so that these numbers don't actually are not exaggerated. Yeah. So yeah. So one thing about the nouns, we have one for minus, and then we have another one for the accounts. Now, for the account, normally, I think, I don't know if I mentioned about the double spending problem, where you with with the it's a problem whereby a person can like use the like spend the same coin twice, though in an elaborate way. uh, it's like in your account you have one bob, you have like 100 shillings, but you keep on double spending that 100 without like ever getting finished. Yeah. So that's the work of announce. Yeah. So this is how a blockchain in simple implementation looks like. Yeah. So yep. I'll push this code on GitHub, and then you can check it out, and then see how you can actually try and simulate your own blockchain. Yeah. So that's it. That is it on encryption and cryptography. And so today we will be diving into smart contracts and the uses of smart contracts. The uses of smart contracts. Yes. Hello. Yeah,
So,
boss.
ca-
Yes.
yeah, can you hear me?
Yes, I can hear you.
Yeah, when we're treating a block,
Mhm,
you make mention that the noun is
mhm,
for to identify each of the block,
mhm.
right? But right now, so that means that the block is doing two functions: to identify a block at the same time to identify a transaction, correct?
Yeah, yeah.
All right, good.
And then if we go back to this, let's go back to the VS Code. If you sorry, if you take a look at the output, it's also hashing the data that comes together with that block. Yeah. So
Yes.
this data. So every block contains these components like the index, the timestamp, the data, the hash, the previous hash, and the nouns. So this data that we have actually sent here, this one, it has been encrypted. It has been encrypted. It has been encrypted into this particular hash, such that this data, all index 2 block, all the components that are in block 3, because this one is block 3, because this is the first block, second block, and then the third block. So this is block 3. So every
Okay.
component that is in block 3 will be hashed, having a unique identifier of that particular block. And that is what lacks in the bank ledgers. So the bank ledger contains data of all the transactions that we have. If we actually go to a specific bank, yeah, let's say the three of us normally deposit and save our money in bank X. That data and we normally do transaction in between the three of us, that data does not contain a unique identifier. It doesn't contain a unique identifier that this particular, it has the date, it has the amount, it has it has the above concept. Yeah, it has the above concept. It has this the above component, the timestamp, the date we did the transaction. It has the data, the sender, the recipient, and quantity, that is the amount of coins we normally send to each other. But it doesn't have this hash. It doesn't have this hash. Now this raises a lot of question, because it's data that can be manipulated. So
Sorry, are you sure another screen?
yeah, I'm sharing another screen, the VS Code. Let me let me share it. I thought you were. Can you be able to see now?
Yeah, I'm seeing it.
Okay. So these components are normally the ones found in like the bank ledgers. Yeah. But they don't have a unique identifier, like to uniquely identify that record and to make sure that that record cannot be manipulated. So actually blocks are records. They are like records chained together with a timestamp and a nouns to avoid double spending or double entry of that data. So with this unique hash, each block has with the addition of a hash in this data, or the encryption of this data using a hash and creating a unique hash, then this data becomes unique and nobody can be able to change it. And then the addition of the previous hash. So if I try to like change this data, which is here, I'll have to go back, because if I change this data, then I will have to change also this other data, cause of the previous hash, and cause of the this hash will change, and the hash has to match the previous hash. the previous hash. So I'll go back changing all that records. And since in blockchain that data, like the more nodes connect to the blockchain, I'll have to go to all the nodes in the network trying to change that hash. Yeah, that becomes impossible, because you can imagine there are like 3 million, maybe 3 million devices connected to the blockchain. And then in those 3 million devices, if you try and change in your block, in your the node, your node, if you change in the first node in your computer or in your node, if you change that data, then you will have to go to repeat the same process to all those 3 million nodes. You will repeat the same process to all the other nodes, which becomes practically impossible, because you will need the entire node or the entire connected nodes to be in sync, or in to be in consensus, so that you can be able to like change everything. Yeah. So, and from what we have seen, it's not possible to like decrypt this one, so that you can be able to like reverse engineer the process. Yeah. So there is a lot of information in one block, and then once now this data, it becomes related in a way, because as you can see, we can have a block that has been made by recipient 2 sending to sender 1, and vice versa, all that repetition. Yeah. So it becomes a good way to like create record, and then you don't need to trust a third party, because now you trust the system, and you trust math, and yeah, you trust these algorithms. Yeah. So yeah, that was it on cryptography. And I yeah, so this one is like the icing on cryptography. Yeah.
So practically, this little programming is on just security.
Yeah. Yeah.
Wow.
So there is a lot. There is a lot. If you are looking to be a developer, these are some of the basic stuff that you need to know. If you are looking to create a smart contract, you will also need to understand, because in blockchain, as I mentioned in the beginning of the course, there are so many opportunities. There are so many career opportunities in blockchain. You can be a crypto educator. You can be you can be a lot. You can be a lot. You can be a lot. And
Yeah.
yeah.
Question.
Mhm.
You can be a lot. It's like you are throwing somebody into a pool of water.
Into what?
I say it's like you are throwing someone
Mhm.
into a pool of water, into a swimming pool
Yeah.
that doesn't know how to swim. I think as an expert, maybe you can, okay, fine. If you want to go into crypto and blockchain, it's either you want to be a smart contract developer
Yeah.
or security developer or a solution architect. You
Yeah.
know,
Yeah.
sometimes, I mean, I'm sorry, judging from where one is coming from, as it is the first time one is having this extensive training on
Mhm.
blockchain and cryptocurrency. So now that we know that there are a lot of great opportunities,
Mhm.
maybe because if you can just look at smart contracts, or you look at crypto, or you look at security and
Mhm.
stuff like that. You know, for example, now in Nigeria,
Mhm.
the CBN, that is the Central Bank of Nigeria,
Yeah.
will be launching its own digital currency come October 1st.
Yeah.
So that means that definitely the Nigerian banks will follow in the same direction, So there is a great opportunity maybe to be a crypto developer or smart contract developer or security developer.
Yeah,
You
yeah,
know,
yeah,
that is
exactly.
just because I want just to be sure because like you rightly said, you are other software you need to know like JavaScript, your Python, and so on and so forth. You know,
Yeah.
so I think it's okay. I think we need you as a guide to hold us by the hand.
Yeah, so that's why you yeah, that's why we are here, to actually help one another understand the opportunities that are there. And you can also be like a crypto consultant. And
Okay.
there is something I've actually remembered. So over the weekend, and I actually saw you, Damaris. You are in a call. That was Cryptocurrency Academy. Yeah, or that was not you. Anyway, so there is this guy who is his name is Brian Adams, and he's a good friend of mine. So we I met him in 2018. The time I was that time I was creating the Ubri coin, and at that particular time he didn't know a lot about. He knew about cryptocurrency and everything, but uh, he has gradually uh, become a crypto educator. So he's a crypto educator, and he
Okay.
started. Yeah, he's a crypto educator, and we have another person who I know. He actually launched his book in 2019. Is it 2019 or 18? His name is Benjamin Arunda, and right now he's a crypto consultant. We've actually known each other like for 2 to 3 years. Those guys actually they started out some times back. Like Benjamin started in 2017 or 16, but they haven't been in they haven't been in the industry for a long time, and they are making a good they're making a good living, and there are other people who have been trading for 2 to 3 years old. Yeah, and they are good, but I normally focus more on development because I believe the developer side, especially here in Africa, we have less developers who are cre- who are experienced in blockchain technology. And if you take a look at and I'm very I don't know whether it's true or I'm sure the Nigerian government somehow they had to like outsource the talent from abroad or something so that they can be able to come up with a coin. And we have developers here in Africa who can be trained to actually create and create a blockchain technology and a solution for Africa based on on our needs. So I normally focus on and I normally say that in development there is a lot, because you can be a junior smart contract developer and within 1 year you with more practice you are good. And that's what we that's where we are heading to. Yeah. Yeah. So with and another good thing is that most of these smart contracts, you can actually find them. They are readily available on GitHub, Also on Etherscan, you can search for a particular token and then go and see how they have implemented different different smart contracts, and you're able to do that. Because I still believe that we are here praising Bitcoin and Ethereum and USDT and other coins, but still here in Africa we don't have like a strong coin that we can be able to like say that this is the African coin, this is the African project. You see,
Mm.
yeah. So those are some of the problems that we are having. We are using tools from outside. We are using blockchains which are actually made yeah, yeah, instead of coming up with a solution that is based on our problem, the solution that is based on our problem, because we whatever Ethereum is trying to solve, as much as they are saying that they want world peace, we can never achieve banking of the unbanked unless the the people who are not unbanked, or the people who want to have that financial freedom, are not involved in the development. Yeah, in the development. So those are just some of my views on the topic of Web3 developers here in Africa, and it's something which is we can change one step at a time. Yeah. So yeah, so we will take a step. Yeah, I think right now we are approaching. Is it how many? I don't know. Mm, we came out from baby pool. Now we are just moving towards the deep end now. Yeah. By the time we are about to complete the class, we will be in the deep end. That is on dApps and on dApps, decentralized application, and yeah. So let's just continue. Yeah, that is just my view on how blockchain can actually change uh, Africa if Africans were really involved, apart from adopting the technology, but adopting means building, innovating on blockchain. Yeah. So uh, that was a recap on cryptography. That was a recap on cryptography and wallets. So we are now on lesson 5, and that is introduction to smart contracts. So you will realize that most of these topics and lessons are more of introduction, because I just want to like introduce the basic concept of everything, so that we can be, yeah. So yeah. So we have traditional contracts, basically traditional smart contract. Basically, traditional contracts are contracts that are governed by it's a legal binding between two parties, or more parties, but it has to be between two parties. Or more people are involved, especially if you are selling, let's say you are selling me your land, and I'm the buyer and you are the seller. So I'll come with my lawyer, and you will also come with your lawyer. So it involves like trusting people, like trusting third parties. That is the nature of traditional smart contract. Not smart contract. Wow. I'm used to the smart contract. That is the nature of traditional contracts. So traditional contracts involved two parties, no, not two parties, but three parties, because of the institution in representation of as the lawyer. So you had to trust the lawyer, or you have to trust a third party. And an agreement does not necessarily mean the paper contract, like the paper contract. It can mean in terms of bank, in terms of the institution itself, like you get into an agreement with with a bank, so that you want the bank to save your money, you want the bank to safeguard your money. And then you can come into an agreement with your spouse, the government, with the issue of title deeds, and also birth certificate. So it actually involves trusting another party, so that it's more of selling a brand than the actual agreement. You, like for example, in insurance, you need to trust an insurance provider, that they will provide you with all the insurance. In case of emergency, they will be able to like cover for you. So it's traditional. That's how traditional contracts look like. That you have to like. Uh, it's more of selling the brand than the services, and selling trust. They actually sell trust to you, so that you're able to invest in them. And now, when it comes to smart contracts, they are trustless. You don't need to like trust them, so that they can guarantee the use of that a specific action will be done. Uh, so smart contracts, a smart contract, there are various definition, because the word, actually the word smart contract was coined in 1994 by Nick S. Zabon. And most people think that Nick Zabon is actually the father of or the creator of the real Satoshi, because he actually came up with the smart contracts way before even the launch of Bitcoin in 2008. Because you can see he came up with the smart contract in 1994. So a smart contract is a computer program or a transaction protocol which is intended to automatically execute, control, or document legally relevant events and action according to the terms of terms of okay. So a smart contract automatically execute and control document legally relevant events and actions according to the terms of a contract or an agreement. So it basically execute all is a protocol that is intended to actually do most of the normal actions or the normal use of a contract. So if it's a buyer or a seller, the same case, the same scenario for buying and selling land, we will only need to come up with events and actions that we want the smart contract to actually have. So if it is the transfer of ownership, we'll create a transaction that performs the transfer of ownership of the title deed to me. Just the like the same way NFT do work. So they transfer all the legal rights to me if I have bought Ambrose land. Then on the blockchain, those transactions will be recorded. So another definition of a smart contract is simply a program that lands on the Ethereum blockchain. It's a collection of code, that is functions, and data, that is state, that resides at a specific address on the Ethereum blockchain. So every smart contract is created with an address. That is the address that we talked about, account address, and that's the code of the functions uh, are are executed in the Ethereum virtual machine. So smart contracts are a type of Ethereum account. Uh, this is another definition of from the Ethereum documentation. So this means that they have a balance and they can send transaction over the network. However, they are not controlled by a user. So that is the best thing about smart contract. No user is able to control it. Apart from where your contract has admins who actually just want to prevent malicious actors from it. You can add administrative accounts. So no user is in control of this account and contract. Instead, they are deployed to the network and run as a program. So user accounts can actually interact with these smart contracts by submitting transactions that execute a function defined on the smart contract. Smart contracts can define rules like regular contracts, the same way a normal contract works, and automatically enforce them via the code. Yeah. So we'll talk a bit about the historical background of smart contracts. So I had mentioned that smart contracts were proposed in 1994 by Nick Zabon, an American computer scientist who invented a virtual currency called Bitgold. That was in 1998. That's why they actually think that he is they actually say that he is the real Satoshi. Fully 10 years before the invention of Bitcoin. So uh, yeah, they normally say that he's the Satoshi Nakamoto, the anonymous inventor of Bitcoin, which he has denied several times. So Zabon defined smart contract as computerized transaction protocols that execute terms of a contract. He wanted to extend the functionality of an electronic transaction method such as a POS, a point of sale, to the digital realm. So, what does that mean? He wanted to like, you see the vending machine that are available like in cafeterias and everything. Uh, that is a basic simple contract whereby you just put the money on the vending machine, and the vending machine gives you like a truffle or some some soda as the output. So that is a contract, and it's something that has been defined by the creator of that vending machine. So instead of now using the physical currency, Nick wanted to extend those transactions to be on the vending machine itself. So in his paper, Zabon also proposed the execution of a smart contract for synthetic assets such as derivatives and bonds. So Zabon wrote, these new securities are formed by combining securities such as bonds and derivatives. That is the options and features, a wide variety of way. So very complex term structures for payment can now be built into standardized contracts and traded with low transaction cost due to computerized analysis of these complex term structures. So yeah, that is how he was able to like define. And from that work, from the work of Nick Zabon, Vitalik would later come on and actually implement those work with the help of Nick Zabon and also Gavin Wood. So you remember the smart contract we had started last, is it 2 weeks, yeah, 2 weeks ago. uh yeah, so this is the contract that we did last week, and we defined some of we defined uh, the variables or the states, and then we created the functions or the code. So this is the functions, these are the states, that is the data that will be stored by these particular functions. So different function performs different uh, actions. So like this one is a setter for setting up the name, and then the other one is a setter for setting up the message. It's another setter function, and then we have a getter function. So uh, so I hope you can still remember the Solidity compiler and the way it looks like, and the way we were compiling and everything. So I'll just do a demo, and tomorrow we will do the entire code again, as I explain different functions. So once you have, we can just deploy it there again and see. So these are the functions that I'm talking about. And this one is for setting the age. So we are setting the states or the data that will be stored in the transactions. And once we have deployed, right now I have ability to like change the data, manipulate the data, because I'm developing. But once I've completely created the transaction, and I'm not the transaction, but the smart contract, and I'm satisfied by the way the contract looks like, I will deploy it into the test net still for further testing. And this is how it should look like. This is how it should look like once I've deployed. So this one is the read part, and this is the write part of the contract. So you can write onto the contract. And now I actually don't have a way to control this contract. I can only write data to the contract. I can only read write. I can only read write on the contract, but I cannot change anything. So when it comes to developing in smart contract, you have to be very careful, and you have to be uh, very, 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 very like you must define everything in the initial planning of your contract. You have to plan everything, that this is the data that I want to store, this is the actions that I want the contract to perform, this is what I want the contract to achieve at the end of the day. So it will basically do the same thing that we were doing. And now this is how now you inject MetaMask into on Web3, so that you are able to communicate with the contract. And once you connect to the wallet, yeah, so you can be able to light, you can actually be able to input the age, can be able to input the message, and you can also be able to set a new name, because you are now signing a transaction, like we have been saying in our lessons. So it, that part, this is the historical background of the smart contracts, and this is what Nick Zabon was explaining, that with smart contracts you can be able to like create, you can now bring the application part of blockchain, the application part of blockchain, like you can create multiple scenario cases where smart contracts can be used. So we have some of the benefits of smart contracts, and the most well-known benefit of smart contract is transparency. So data stored in the blockchain is available for everyone to see. We have efficiency. So there is no room for misinterpretation or lost document. Code is the raw, is a popular expression that describes this behavior. And then we have cost reduction, as middlemen are cut out and the costs are significantly reduced. So we go back to the case of banking. So this time you don't need to like trust a third party. And there is something that I wanted to explain in terms of bank and how bank actually manipulates our money. So mostly when you do save to your bank, when you save in your bank, let's say you save like 100 Kenya shillings, they normally lend 10 shillings. So in your bank account there is 90 shillings. So let's now say we are the three of us in the bank. The bank will lend 30 shillings, and then they will actually charge you for saving there, so the bank actually benefit more from your money than the way you benefit from them. And making your that is making your money valueless. It makes your money valueless, because like the case of Nigeria. If somebody has I've been seeing some of my friend saying that they saved like actually Ambrose is the best person to actually tell us.
No, I don't know what you are talking about, Nigeria. So maybe you just say that, and maybe I can confirm it.
Yeah, you can confirm it. You can confirm it. Somebody saved like 10,000 naira, but right now when they tried to convert it into USD, the money was less.
Yeah,
So
that is the
yeah,
exchange rate now.
yeah.
The naira to dollar every day keep changing. So if you
Eh,
have 10,000 naira in your account,
mhm.
and maybe as I tell you are putting that money there, that 10,000 naira is like saying is $200. Hmm?
Yeah,
So the bank always go with the black market rate to give you your money. So if
if that $200 now, because of the exchange rate, now reduced to like $120, that's what the bank will tell you. That sorry, that is the exchange rate now. So
So
so the exchange rate is not fixed.
yeah, that is the situation, the current situation in Nigeria. And another
Yes.
thing, sometimes back in Greece, uh, the country was going in recess, and the country actually blocked people from withdrawing their money, like money that you legally own. The bank is telling you that you cannot withdraw your money, and that is your money. So the bank actually are the beneficiary of what you save. And with smart contracts and blockchain technology, you are now in charge of your money. Nobody is in control of your money. You can access your money wherever you want your money, whenever wherever you are, without any border and without need to trust a third party. So you can imagine such a scenario whereby you there was this particular somebody, I think it was in the movies or something, and she was saying that that's why I normally save my money in my under my mattress, because there is because there is no trust with the bank, because anything can happen. No, in the olden times, banks used to be banned. Banks used to be banned. Now you can imagine a bank being banned, or
Mm.
something, or a fraud happens, and then the bank is announced bankrupt, something like that. So with smart contract, these traditional forms of agreement can be now be represented in blockchain with transparency and efficiency and cost reduction, and the cut of middleman. And also there will be security because of the cryptography. From what we have learned from cryptography, is used to secure transaction and prevent attacks like double spending. Yeah. So then we have the composability of smart contracts. So smart contract are public on Ethereum and can be thought of as an open APIs. So anybody who wants to like use the smart contract for their needs. Let's say you want to use a smart contract for your hospital. You can actually grab those API and integrate them into your hospital records. So that means you can call other contracts, smart contract in your own smart contract to greatly extend what's possible. So contracts can even deploy other contracts. So there are contracts which can deploy other contracts, and yeah, in basically what blockchain is doing is or what smart contract are doing is decentralizing decentralizing the tradition, the traditional form of creating contracts or getting into an agreement with people. That is the work of smart contracts. Yeah. So I didn't want to. Yeah. So that is how what smart contract are doing, and how beneficial they are when it comes to actually being in control of your own funds. Now, another case scenario for where smart contract actually can apply greatly is in uh, transportation, like Masek. So Masek is the transporting country or the container industry, and there are other third-party companies that actually they create agreements between them. But with the addition of smart contract, there wouldn't be a need of the third party or brokers. Yeah, and especially here in Africa, you have a lot of brokers in different industries, and with smart contract, we can be able to like eliminate such people or such entities, thereby giving like in the coffee industry, and also in the cocoa industry. Yeah, yeah. Is it yeah, cocoa industry? There is a lot of brokers, and from recent findings, not findings, but documentary that was exposed how kids are used in the harvest of cocoa, but they never get money, or they never get rewarded for what the work they have done. We can actually use smart contract to see the process from the process of farming that cocoa to the process of harvesting, all the way to the process of getting that cocoa into the market. The same case for coffee, the same case for maize, and Ethiopia is also in the process of like coming up with what do we call it? ETH, Ethiopia something, ETH. Uh, it's, ETH. Uh, Ethiopia ETH. I think it's coin. Yeah. So it's now the second cryptocurrency to get a logo on. So this is something that I saw. Ethereum community backs Ethiopia ahead of there was something yeah, that was Jack Dorsey, and if you listened carefully to the B word on YouTube, he talked about a woman in Ethiopia having to like have difficulty in accessing her funds and things like that. Yeah. So those are some of the problems that smart contract can solve. Yeah. So let's just dive into the code, and we will complete the code that we started. Uh, for Ethereum, not smart contracts are written in Solidity. Solidity is a higher level programming language that is used for creating smart contracts. And then we have the EVM, Ethereum Virtual Machine, where the compiled codes are compiled into bytecodes for the Ethereum Virtual Machine. And then we have what we call gas. Is gas fee, or gas is what you pay for, is what you want to like for example, if you want to go to a place like Mombasa, you will need to pay for fuel so that you are able to get to Mombasa. So the amount, or it's the amount that you are willing to spend for a certain action to be completed. And I've also talked about the state. The state is the data, and I've also talked about the functions. So functions are the codes that are used to actually manipulate the state of the data. And then we have we have remits IDE. Remits IDE is where you write your code, and we have the so by now I know we have what we sorry. By now everybody has is on the address, yeah. Hello.
Yes, we do. I think we
Yeah.
have 5.
Yeah.
5 each.
Yeah. So I also sent you Damaris. So I know I don't think so everybody has it in their MetaMask wallet. So I'll just explain the code as we do it, and show you how to create a new file. And the extension for Solidity file is .sol, just the same way we have .doc, .jpeg, .pdf. Yeah. So
Yeah. Question, please.
yes.
The Solidity,
Mhm.
is there a I mean, do you execute it from the VS Code, or you have to download the software? Is there a software for that?
So for that, tomorrow we will do the setting up. We will set up the tools. We will set up the tools tomorrow.
Okay, great.
Yeah. So for now, we can use the online IDE, but there is a way you can set up your VS Code. Uh, let me just show you how you can set up your VS Code. So if you already have the VS Code in your system, you will need to install a plugin called Solidity. So this one, Solidity, it's an extension. This one, it's a plugin or an extension. So you will need to download and install it. So this Solidity, one thing it does is syntax highlighting. It helps you to highlight just the same way you can see here. It has highlighted the keywords of Solidity that are already inbuilt in the Solidity language, and also it helps you to like highlight your so that you can able to like for easy debugging. Yeah, that is Solidity. And then you will also need something called truffle. Truffle is not an extension but a framework. It's the same as npm. It helps you to interact with truffle. Know whether I uninstalled it. So let me just share those links so for you can be able to truffle. Ethereum truffle. Ethereum framework. So truffle suite is a tool used for smart contract development. So let me just share. You can install it in your so that is the link for truffle. So is a world-class development environment for testing, testing framework and asset pipeline for blockchain using Ethereum virtual machine. And then we have another one is Ganache. Ganache is a personal blockchain for Ethereum development. You can use to deploy contracts, develop your application. So this is what I was local network, local blockchain network. So you can also download it and install it in your system. Oh, and programmers like sweet stuff. So it's Truffle, which is also a chocolate, Ganache, which is also a chocolate. They like sweet stuff. Ethereum is sweet. So this is Ganache. And then we have, you already have MetaMask. So I hope the other tools or the other links that I provided you are able to also install in your machine. If you are having a problem installing them, kindly do contact. I'll be glad to help. We can have a Google Meet, and then I help you to set up your environment for this week's development. So we will basically be looking at different contracts, how you can create, how different contracts are implemented. And by Friday, hopefully, we will be able to deploy an ERC, a simple ERC20 token. Yeah, we will be able to create our own coin, hopefully.
Okay, great.
Yeah.
Great. Is NPM same as Ganache?
NPM is not same as Ganache. Ganache. NPM is a package. NPM is a package manager. It's not package manager. It helps you to install packages. It's an easy way to
Okay.
download your packages. So NPM is the same as Yarn. Yarn is also used for package management, for downloading. So Ganache is a command line tool for it can be a command. It's a command line tool for creating your local development, like this one. Let me just open it, and I show you Ganache. Trafo is what can be the same as Trafo is what is almost similar to, oh god, don't know who came up with this Ganache cause must have been eating some Ganache. Let's just wait. So it's a local development blockchain. It's a local development. You can install it globally, or yeah, globally will do. So if you have npm as your node package manager, or if you have Yarn, that will be okay. I'm waiting for the Ganache to open up so that I can show you how. It's the same way as what we had here. You remember the wallets we have here, these ones. Hello. don't know, it's taking time to like
Yeah,
oh yeah,
man.
it started. Didn't know that Ganache has already started. Yeah, so this is Ganache. This is how Ganache looks like. This is how Ganache looks like. And you can create a workspace. You can create a new workspace. You can have a quick start. And so I have created previously. I have created some workspace, and this workspace actually, instead of creating using the limits IDE with all these, because you will actually use a lot of data when you are using or you will spend a lot of time while creating your smart contract. You need to have a local development network. So this is the kind of the types of network that I was speaking about. So local network are basically used for local networks are basically used for local development. They help you in local development, and they give you the same. They give you they give you the same experience as this one. They give you the same experience as this one, but the limits IDE. So once you deploy your contract, it's yeah. So this is my workspace. So I've been given like 10 addresses with 100 ETH, 100 test ETH, together with their private key. So I can show the private key. So these actually don't, they are just for the purposes of development and testing and using on blockchain. And then we have the blocks here. We have the transactions. So transaction will be recorded here on the local blockchain. And then we have the contracts. So once you deploy, your contracts will be here. So I have the contracts here. The contract, it says that the contracts are not yet deployed, but it's because I haven't started the project. If I start the project from my VS Code, then I'll be able to like see all the contracts that I've been able to deploy in Ganache. And then I have the event logs, or the events that have been emitted by the contract. So you have the event name, it can be withdraw event, and then the transaction hash, and then the block time, and then the contract, as you can see. So this is Ganache. It's as a local development local network. This is what from the types of networks that we studied from the Ethereum. Yeah, so that is a local network. Yeah, so we will be alternating. We will be alternating. I don't know if yeah, so we will be alternating. We will be using the Ganache, the local development, and also limits IDE. So limits IDE, if you find it hard, like using Ganache, and if you find it hard to use Ganache and everything, you can always go back to limits IDE. Because one thing about limits IDE is that it has that feel, that user-friendly feel. It's user-friendly when it comes to development. When it comes to development, because it offers this graphical user interface feature where you are able to like simulate your transaction, where you are able to like see what you are inputting. For local development, it's a little bit complex, and you can actually kind of give up development of smart contract. But either way, whichever tool you use, it gets the job done. It gets the smart contract created. Yeah. So I think what I will do, I'll actually upload this code in GitHub, and then you can take a look at it and practice and see how you are able to like deploy, how you, if you can be able to deploy and do some test. So I'll do the deploying and verification of the code. I will verify the code on blockchain, all in the test net, so that you can be able to follow the same process. Yeah. So this one we have already gone through together in a previous class. It's just some completing or some changes you will be able to do. So I did some modification on the code. This is also another way you can actually like be able to highlight all the Solidity compilers. So this one is an increment. It shows that from 0.6.0 going upwards, use that compiler from 0.6 all the way up. It's the same way as what I had defined earlier. And also remember the licenses. You have to keep to add this line here. If you remove it, your code won't be able to run, because if, oh, interesting. The last time it was not working. Yeah, you can either add it or remove it. But it's good to actually have a license identifier, so that your work your work can either be open source, or if you want people to like actually buy the license, so that they can be able to use your code. So it's good to protect your code, to always protect your code. And then we have the contract. The contract is the keyword to actually initialize a contract. And then we have the name of the contract. And then we have the variables declaration. Just like the normal program, you need to declare variables. And I've declared a private username, which is private. And I've actually added my name here as I can leave it empty as an empty string. I can leave it as an empty string, or you can leave it. You can also, there is a way you can be able to actually change that name. So I'll show you in a bit how you can be able to change that name once you deploy your contract. And then we have string message. And then we have, this one is not private, it's actually public by default. And then we have uint private integer. This is an integer of age. It's a number. Integer is a number which represent, it's a private number which represent or stores age of a person or something. Then we have the setters. So we have the keywords, as I have mentioned, keywords, contract, string, strings, uint. So if we try to like use string private string, we will be using keyword, and the compiler will throw an error. So expected identifier but code string, string private string, we cannot use reserved words. So these are like reserved words. So we cannot use reserved words that the compiler uses to compile. So you need to like be able to know the words that are normally used by the compiler. So these words which have been highlighted, we cannot even use private here because it's a reserved word. See, we cannot, the compiler will always throw an error. So you need to come up with. So one thing about programming is that when it comes to variable declaration, programmers are good people who come up with good names. Yeah. So yeah, if somebody is having problems with naming, they can always ask a programmer. Then we have memory. Memory is reserved storage. It's a storage that you want to reserve. So this kind of memory that we want to reserve, it's a string memory. It's a memory. So computer allocates or the compiler will allocate memory depending with the variable or the keyword that you have used. If it's a string, it will be stored. It will be a memory stored with a string. So a string is has. You remember the characters that I was speaking about. So we can have a string which is maybe like 100 characters or 200 characters or 200 characters. So if I write more than 200 words, those words won't be able to fit because we have allocated a memory of like 200 characters. So if we exit with like five to that will be 205, then those characters won't be stored. The other 5 characters won't be stored. So that is memory allocation. So you have to know that you are allocating memory to the Ethereum virtual machine, and this is what will cost you. This what will because if you can remember from our previous lesson, we said that gas fee or transaction cost is depends with the operation that you want to perform in your smart contract. Uh, yeah. So we have public. Public can be accessed publicly by anyone. That's why we have the variable word here. No, not the variable word, but keyword public. So these functions can be accessed publicly. If we try and add private, if we add private and then we go back to our code here, and deploy it, then we won't be able to see set age. We won't be able to see the set age because it's now private. If we even change here, if we also change here to private, the same case will be. Just a minute. Let's just deploy it again. So you see, we are now available, or we can only access these four functions, because the other two we have made them private. So private means that only authorized personnel or authorized or the owner of the contract can be able to like access these functions. That is so this is the public view. So it's a public view. It just means to view, like it can be viewed, and then it returns a uint, an integer. It returns an integer as the output. This one also returns a string as the output. It returns a string as the output. This one also returns a string as the output, which is a string memory. And then this one inputs or saves an integer. It saves an integer to our variable, this variable now, which we declared private, as the age. So it replaces, if you add age here, it will replace it. As we continue on, as we go on, we will be able to see how now you can create something like struct a structure. Supposed to be brackets. Okay. Yeah, this is not how you write a struct, but I'll show you how to write a struct. So a structure, it's supposed to have a struct person. It's supposed to have a name with this kind of brackets. I might forget. And then you define like person, like string person, string name. It's supposed to be equals. Well, so this structure or this struct that I'm trying to define here is a way that you can now like store different records of particular people. Like if you're creating a school smart contract and you need to store students' data, then you will need to create a structure, a struct. Like let me show you like this one. Yeah, this is actually the way. Don't know why I'm getting an error because it's the same way. Same way. So like this one is a ballot contract or a voting contract, and we have struct voter. So this is the voter information, and these are the proposals of persons who want to like vie in the contestant or the people who are participating in the elections. And then we have address public, like the chairperson of the electoral commission of a particular country. And then we have the mapping of all voters. So once you input all the voters, then mapping of address will come from the voter struct, which will be public, and it will be stored as, or it will return a list of all voters who are in that particular country or place. And then we will have an array of all the people who have been proposed to be part of the elections or the candidates. Yeah, so that is the ballot, and we'll come to see. For now, the implementation is just simple. It's a simple contract to actually define as we go. Yeah, as Ambrose said, like right now we are in a swimming pool, so we want to know how to do the backstroke, the back flip or something. Yeah.
It's true now.
So yeah, so right now we are trying to like learn how to hold our breath inside the swimming pool.
Yeah.
Yeah. So I've actually explained how this code works, and the next step is yeah, so the next step is you have to like always remember the environment you are working in. If you want to see it on link-based testnet, always remember the environment. And also always remember to always check the network you have selected in your MetaMask wallet. There was a time I had selected Ethereum mainnet, and I actually deployed the contract code without having completed the testing. So this is something that you need to do, because it will cost you money, like real ETH. It will cost you real ETH when you are in the mainnet. It will cost you real Ethereum, and that's a lot. So you need to select and make sure once you have selected the test net, remember to select environment, inject Web3, and then it will show you the network, that is the link bay. It's network number 4, and then it will show you the accounts that are connected with the total number of if that you have. Then gas limit will always be like that when you are deploying, and then the value in WAE, and then because sometimes you may have a lot of files that you have opened here on link bay, not link bay but limits IDE. You may have a lot of files. Always make sure that you have selected the correct file, or the correct contract, and then you can have you make sure that the contract, the one which is here, it's the one which has been selected. When we will be deploying or creating an ERC20 token, we will have like multiple not coins but multiple contracts, and this phrase will actually will have a lot of you will have to like select the main the main contract, the real contract now, because in like let's say we are creating an ADS coin, we will have ER interface ERC20, we will have a safe math contract, we will have an ownable contract, and we will have the main coin, that is Africa Data School ERC20 token. That is will be the main file, and then the other, it will be like our entry point. You remember the way we defined app.js, this one as the entry point of our program, of our program. So the same case, you need to like have an entry contract, like the contract that will be like the entry point of all the other contracts. So always remember that you have, before you deploy, always check the contract that you are deploying is the entry point of that, of yeah. Then if you want to deploy like what I'm doing, you just need to come here and copy your wallet, and then you paste it there, and then you will be able to deploy it here if you don't have time to deploy it to the test network. This one will be for faster development and testing, to see if all your functions are being outputted. We didn't change this one, so we'll get it back like that, and then we will deploy again. So every change you make, you will have to deploy. See, now it's now visible. It was private, now it's public, and it's visible by everybody, for everybody to access. Then once you have done that, this one now you can be able to deploy it to the test net. It will actually initialize, or will initialize the smart contract, not the smart contract but MetaMask wallet, so that you can be able to sign the transaction. So if I hit the button deploy, MetaMask should pop up for me to like sign the transaction. So this transaction is contract deployment. That's how it will be recorded in my wallet. And then as you can see, the gas fee in WAE, and yeah, so this is the money that I'm willing to actually pay as gas fee, so that I'm able to complete the or deploy the contract. So I'll deploy, and then I'll go back to my MetaMask. So the contract has been deployed. can go to the transaction and view. And then let's wait for it to be validated. And there, so it has been validated. So this is the address from the value of ETH and then the transaction fee. And this now is the contract address that we have deployed to. So we'll go to this contract and see the details. So this is the balance that we have been talking about, that every contract contains an ETH balance. And once we have deployed it, we have no control over this contract. So I'll also share this contract with you so that you can also interact with it during your free time. And if you are successful to deploy your contract, you can also share your contract on the group. Yeah. So all transaction will be recorded here. All transaction will be recorded here. So this is the data that I was talking about, the from who, the value, that is the quantity from the simulation that we had, the age is the time, and then from to, and then this is the transaction hash. Yeah, then we have another, that is the tab for transactions, and then we have contract. This is where now we will be able to read and write. And for you to read and write, you must verify and publish your contract. So we will do that right now. We will verify our code. So remember, we had gone through this project, but the previous class we were not successful. So hopefully this time we will be successful. So you will have to, the contract address will be out of field because you're verifying this particular contract which has been created. You will have to select the compiler version as a Solidity single file. If it's a Solidity multi-part files, that is, you have other files accompanying the contract, the entire contract. You will need to say that those files are in parts. If it's a single file, you remember me saying that all in the previous class, saying that you can create multiple contract in the same file. You can actually initialize another contract here. Contract, other contract, and then employ your logic there. You write all your logic there, and then this is now what we this is now what is called Solidity multi-part files. And then you can have a standard JSON input. A standard JSON input if you're locally developing. And this Solidity standard JSON is provided here as artifacts. So this is it, the artifacts. This is the standard file. So it has the same thing. It has the inputs. It has the get message. This is the method. It has the, you see, it's of type string, and it's a name. You will have to input, like you will have to, not the name, it's supposed to have a name. So this is the standard JSON, or the artifacts. And then we have the Keka 25, it's similar to secure hash 25 seats, 25 seats. And then we have the EVM version. It's from Instable. And then we have the compilation target and the name of the, this was a previous one. This was a previous artifact that I had created. So it does not have the, it doesn't have this name. So this one is the one that has the name as the Africa Data School. This one. Oh, This one. This one is the one which has the. Oh no, that one is .json metadata. So this one, the standard JSON format is the one that contains the name, and then we have the license, that is GPL license. So you can either paste this one and then it's version 1. So you can either paste that one when you are validating your file. So your contract. So we will select the compiler as Solidity single file, and then we will have the compiler version as 0.6, and then we will select the license as the MIT license, and then we will continue. So once we continue, we will be provided with another page. So this particular page, we remember to, if you have optimized your compiler, remember to always say yes here if you have optimized your compiler. And then below is where we will now enter our Solidity code. So if your contract has constructor argument ABI, you can actually paste there. If your contract is using libraries, you can always paste them there. But most of the contracts, or the contract that we'll be creating, we won't be using a lot of libraries, and compiling or deploying won't be a big problem. We won't have constructor argument APIs. So we will come back to our Solidity compiler, and then we will copy our code, and then we will paste our code here, and then go there at the bottom of the page. We will have to approve that we are not robots, and then we click on verify. So it should verify. It will take a few minutes. If your code works well on limits, it should also work well on while you are verifying. So let's see. Voila. And we have been able compiler version 06. Oh, there is another contract with the same name. So we'll have to change the name and deploy again. We'll have to deploy it again because we have another contract with the same name. So found the following contract names in source code, Africa Data School. There is another one. So it's this is an update that Ethereum did recently, because people have been using same contracts. So yeah, so we will deploy it again, and then we will confirm. Yeah, so we are good. And then let's just close that one. It's something that they have added in their recent because then the compiler version 0.6, then MIT. Then we agree to terms. And then optimization, yes. Code there. We are not robots. And then verify. Our host failed to mention how I began my career as a struggling nurse. During the times when such an opportunity was incredibly rare, especially for a woman who was poor like I was. Okay. But I persevered. There were many who said it's a valid contract. What it takes to be a surgeon. But I still continued to study medicine during a time where many would laugh, would raise their eyebrows. When I opened my very first beauty clinic, I persisted. And you know what? I've learned a very important lesson in life. If you want your face to become beautiful, you need help from a doctor. But if you want your life to become beautiful, all you need is yourself. 029. Your own belief. Think let me just try again. To achieve beauty, we offer nothing but precision and perfection. Thank you so much. So MIT, continue. It's a single file. So yes. Verify. Okay. This is weird. Have enough internet. Okay. Let's just take a look.
Do you have to put the contract byte code and API?
Yes?
I said, do you have to put the contract byte code and API because it's like
No.
it's allowed to generate it?
No. You don't need to put constructor APIs or contract libraries. For this particular verification, you don't need to like do that. I'm not sure why it's not working, because I had actually deployed this contract like a few hours ago here today. Actually, this was today. Yeah, this was the one that I had validated, and it worked. So it should actually look like this. This was 4 hours ago. So once you have validated, oh God. Let me just see. Yeah, there were two contracts that I did deploy. Yeah, this the this is the one that I had validated. It's the same one. It's the same one. So once you have validated, it should look like this. So contract name is Africa Data School. Its optimization is enabled. That is 200 lands. Default EVM and the MIT license and the compiler version. So this is the code. This is the code. So we can actually try and write on the contract. So we can set the age to like 10, and then we write onto the contract. So we need to connect to MetaMask so that we are able to sign a contract. So right now anybody can actually interact with it, and then we will pay for this transaction to happen. So yeah, and then a button will appear for view your transaction. Then once confirmed, the transaction will appear here. So as we wait for let's wait for the transaction to actually to be validated. You can refresh as you wait to see if the transaction has been validated. Yeah, so the transaction has been validated, and then we can go to our contract and refresh the tab. Yeah, there. So our transaction has been added. Our transaction has been added, and then we can go to our contract here, the contract tab, and then we try to read the age that we have just. So we can get the age. As you can see, the age is 10. The age is 10. So we can also add a message here and just say sometimes code won't work. Sometimes code works, sometimes it don't. So that is the message, and then we will sign another transaction. It's the same process that we were doing here. It's the same thing that you can do here, but now you're doing it now in the blockchain. So we should let's connect to the MetaMask, and then a transaction should appear, should initiate the MetaMask app to pop up. Then, as you can see, you can see the name of our transactions. The name of our functions is the one which is been. The activity now becomes now like set message is the function that we defined here. So those are the name of our action, or the name of our operation, or the function of the code that we want to actually implement. So we have set the message, and then if we go back to read, can try and get let's just refresh the contract again and go to read. So we should see the message that we have added. So sometimes code works, and then we can get the name. So this is the name that I had made as a private variable. But since the function and the get function is public, it overrides that private, and the string is now visible for public. So yeah, that's a simple implementation of a simple smart contract. Yeah, so tomorrow we will learn more about smart contracts and their limitation and the security. So most of these things we have covered in previous lessons. That is the delegate uh, security problem. We also talked about the overflow problem. Yeah, so we will see. Yeah, and we will also be able to like implement different codes and everything. Yeah, so I'm not sure why. I'll actually go deeper and take a look at the reason why this sometimes does not work. It actually does not work when I'm presenting. I don't know why this code or this contract is not validating or verifying. But yeah,
Could it be that is he referring to the same contract since you say you ran it before?
the code is the same, but the address shouldn't be the same. I've actually changed the name to be unique. There is no other contract which has been deployed with the name data school. Let me see if there is, because it could mean that I'm deploying the same contract. I'm actually verifying data school is not currently registered. It is available for registration using not that one. So there is no name like data school. So the contract should actually verify.
Oh.
I found the following contract name. I'm not sure why, because I don't think it's my internet. Because if it's my internet, then even the deploying would be a problem. But this is the process for for validating. This is the process for verifying. This is the process of verifying. So the EVM actually tried to like look for a match from the list of compiled contract bytecodes, but it was unable to find a match of this contract. So yeah, I'll do a clean upload tomorrow. I'll do a clean upload and with a different name and a different wallet. I'll use a different wallet. Yeah, a new wallet. Yeah. So yeah, you can try that. You can try that. You can on your side. You can try that, and yeah, I'll share this contract. Uh, I'll share this contract on the chat and also on GitHub. Oh, yeah. So you can copy it and try it. Yeah, on your free time. Yeah. So once you are able, if you are able to deploy the contract and verify, you can share your link on the group, and if you have a problem with the code or setting up your environment, you we can have a call in the afternoon before we start the lesson, and then we set up. So I help you set up the environment, if that's okay. Yeah. Hello. 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 Hello.
Hello.
Yeah. So if you have a question, comment, or anything, you can ask.
No.
Okay. Yeah. So were you able to like set up the tools that I had provided, like the npm and the rest?
No, not yet.
Okay. Okay. Yeah, it's looked like Ambrose has dropped, but yeah. So far, how is your experience?
I think it's interesting.
Okay.
Mm.
Is
But the coding part, I think kidogo, because my knowledge in coding is very basic.
okay. Yeah. So I'm actually trying to make it as simple as I can, because I know that yeah. I'm more of a developer, and yeah. Anyway, that's it on coding. Just stop sharing. Yeah. So that's it on coding, and those are some of the few things that you need to like understand, and you will be good. You will be good. Yeah. It's just a matter of like practicing day in, day out. Yeah.
Okay.
Yeah. So if you like practice like simple, you start simple. I've seen people start coding while they are 30, not 30 but 40. Like
Sorry, I lost network.
it's okay. So I've seen people start learning coding while they